Hello everyone. Previously we have discussed two properties of system, that is system with and without memory, invertibility and inverse system. Now we'll discuss the causality. So for the definition, the output of a causal system does not depend on future values of the input. So the output of a causal system will depend only on the values of xn for present time or past values of time. So they are not dependent on the future values. So suppose we have a system xn. So suppose we have a system yn which is equals to x of n minus 1. So here the output is totally dependent on the values which are past values of n. So that's why this system is said to be causal. But suppose we have a system like yn is equals to xn minus x of n plus 1. Here you can see that for a present time stamp of n naught, the value of output will depend on not only on x n naught but also the future values x n naught plus 1. So this system is an anticipatory system and it is non-causal. Similarly, for like the continuous time case, we can write yt is equals to x of t plus 1 will be a non-causal system. So can we relate two system properties? Suppose we have already read about memoryless system. So can you guess like memoryless system is causal or non-causal? So as we have defined that a memoryless system is only dependent on present time. So the output of a system will be dependent on only the present value of input. So suppose we are taking the output of a system at a timestamp of n naught, so it will only be dependent on the present timestamp of n naught. So that's why all memoryless systems are causal. So this can be generalized. And similarly, we can say that system with memory can be non-causal. So now we'll solve some examples to understand the causality of a system in a better manner. So we will take the example 1. So we have a system whose relationship is defined as yn is equals to x of minus n, and we want to check that this system is causal or not. So we will first take a timestamp. Suppose n naught is the timestamp, that present timestamp, and as per the definition we know that if y of n naught will be dependent on input at any time which is present or the past values, so it cannot be dependent on the future value of the timestamp, so then the system will be causal. So at first instance it looked like that this system is causal. So suppose we have taken a value of n naught as 4. So what will y of 4 will be? It will be equal to x of minus 4, and we can say that the present value is depending on a past value because minus 4 is less than 4. But if you take a value of minus 4, so now we are taking n naught as minus 4, so then y of minus 4 will be equal to x of plus 4. So in this case you can see that the output at minus 4 is dependent on x input at a value of plus 4. So the output is dependent on a value which is a future value. So the system will be anticipatory and thus it is non-causal system. So the system will be non-causal. So you have to look carefully that the system is depending on future values or not, to judge that the system is causal or non-causal. Now we'll take a different example, which is for the continuous time case. So we have yt, which is equal to xt cos of t plus 1. In first appearance, it seems that this output is dependent on a future value t plus 1. So the system will be non-causal. But this is not the case. We have to carefully examine the system. So we are only interested in the values of the input. So this system is a resemblance of a system which is equal to xt into some g of t multiplied by x of t. Here this g of t is time varying function, namely gt will be equal to cos of t plus 1. And this value will be a constant. So here what is happening, that yt will be dependent on xt with a value gt which is a constant value. So the in present output is dependent on present input stamp. So it is the case of a causal system. So be careful while judging that the system is causal or not, because at a simple glance it was looking like that this system is non-causal, but it seems to be causal, and the previous one which was looking causal was not actually causal. When we taken consideration the depth of the concepts, then we find that this system is non-causal and the example number 2 is causal. So this concludes the causality of a system.